So, I don't really understand the question about the bullet going in the box. So, you always say draw a picture first. So, here's the block, here's the bullet, that's not a very good bullet, whatever. And then here's, this is before, so this is the block, oh my god. So, okay, here's the horizontal plane, this is the block. It was displaced a little bit, and the bullet is inside it.
Yeah.
This is X, which is 0.23, so it's inelastic, so then we can use conservation of momentum.
I would think so. Start out with that and see what can happen. You know, who knows what could go wrong. MV plus MV equals M plus M. V final. Of course, this is bullet initial. This is block initial. Bullet block. All right, and we're basically
solving for the V final.
V. We're solving for this one. We don't know this, right?
Okay.
V initial.
Because we know V final is 0.
Yeah, and we know the velocity initial of the block is 0, so that whole thing is canceled out. So basically, since we're finding that, let's just solve for V of the bullet. And that will be N plus M over VF over the bullet, the mass of the bullet. And block. Alright. But we don't know VF. We don't know the final velocity. But we do know like a displacement. So probably could use a motion equation. This is all Newton's motion.
Oh, those are all motion, okay.
Yeah. Plus 2a change of x.
So we don't.
I like this equation.
Well, why do you like that one?
Because we have no time, no time.
Oh, okay, so we don't have time, so that's why.
And we know that this VO is right here.
Yeah.
Is right here. And that actually is the final of here.
Yeah.
Okay? Alright. And we know this final velocity stops at that point, so we know that's 0. So basically, this will be VO2 plus 2AX. Just move that over here. Negative 2A change of X equals VO. But we don't have
A.
A. Okay, so how are we going to find A? We do have like a
Kinetic.
Coefficient. Yeah, of friction, right?
Yeah.
So we can draw a force diagram.
Yeah, okay.
See that, young friend?
Yeah. Okay. This is the bullet and the block.
Yeah.
So first is the gravity.
Boom, boom. Mg.
This is the normal force.
There's always an opposing force when it's on the surface.
There is friction.
Opposing force on the surface. There's always a normal.
So we put some of the force.
Some of the forces.
Yeah.
In the x direction.
Is just the F.
It's just F.
Yeah.
And F. Yeah.
And the y direction is minus
mg equals
0. This is negative.
Yeah. Yeah, she has a negative.
Alright, wrong side. Okay.
Yeah.
Good job.
Yeah, thank you. And so the friction equals the mu times
G.
So from here we can get the equal mg. So we can come here and F equals mu times mg, and so we know equals ma,
and then our m's cancel.
So the
A equals u. negative. Yeah.
Negative, yeah.
Oh yeah.
So A equals
Negative
mu
G.
So
Okay, so that means our mu k is 0.2 times our acceleration is, G, 9.8 is 1.96. So we go negative 2 times 1.96 times our change of x, 0.23. Excuse me, that's a negative 0.96. Alright, equals VO. So that would be times 2 times 0.23. Okay. Equals VO equals 0.9016. Alright.
So then we can just plug this in
To
to
that.
that equation.
Boom, boom. And that will be, so BB equals mass of the
5
bullet.
grams
5 plus 1.
1.2.
Oh wait, this is grams.
Oh, 1,200 grams.
Oh, we should use kilograms.
Yeah, it's use kilograms.
Use kilograms.
So change that to
1.2.
You have to change the 5.
change that to 0.005.
0.005. Good, moving along, all over 0.005, correct?
Yeah.
This is 0.9016. Okay, here we go, 0.005 plus 1.2 equals that times 0.9016 equals that divided by 0.005. So the velocity of the bullet should be 217 meters per second, but sig figs, so it should be just like 220 meters per second.
Okay.
Which makes sense because the bullet travels super fast.
Yeah.
But I heard I think there could be another way. This is super long. I think the total kinetic energy equals the amount of work.
yeah.
And we totally have the amount of work, right?
Yeah.
Should we do it?
Yeah.
Okay. Don't you know what I'm talking about? Go ahead.
Show it, Young Fei.
So that makes sense, right? Alright, here we go.
Okay.
Yeah.
So from here to here, there's only friction force that work on the block and the bullet. So we can use the change of the kinetic energy of the block and the bullet. Yeah.
Yep.
So the work
Equals
delta kinetic
energy.
So the work equals
Force
force
times
times the distance, and the energy is delta energy equals the final kinetic energy minus kinetic energy of the initial. So we know the friction. Okay. The friction equals mu times n times s. And
equals
equals.
I get it.
So
equals 1/2.
Yeah, 1/2 mv final.
Square.
Yeah. Minus mv.
Okay.
So then
We have all that. Do we have? And we have initial that because we did this from
That equation over there.
from that equation.
Oh, sorry.
From that equation.
Yeah.
So basically, we have that. We have that, and we're finding this.
Yes.
So basically, we found this from something over here.
Yeah.
So what we're trying to do is we have every freaking variable,
Yeah.
and all we have to do is solve for V, O, and then we get our answer.
Yeah.
So basically we just plug in the numbers and
Yeah.
that's it.
Yeah.
Alright. Okay, I get
So there's
that.
2 ways to do it: long way and super short way.
Okay. I understand it.
Well, we just did this because we didn't know what the heck we were doing, but we did end up at the right place.
Yeah.
Alright. Cool.
Alright.